This is Jack Jackson back with the last of our series of 8 videos on solving right triangles, and I definitely saved the hardest case for last. This is the only other case that's available, and that is where we have the area and the hypotenuse. Okay, the area and the hypotenuse. Now, this one involves a little bit more algebra than the others, so let's take a look at it. The area is 1/2 a times b. So like the last one, we're going to set up two equations here. One is going to find b in terms of the area in a. So b is 2k over a. This is like our last one. And then we have the Pythagorean Theorem that a squared plus b squared equals c squared. So substitute 2k over a in place of b in this expression. And so we get a squared plus parentheses 2k over a close parentheses square equals c square. So squaring everything inside here, we get 4k square over a square. Now we have an expression that has fractions in it. So I'm going to multiply both sides of the equation by a square to cancel this fraction out. Cancel the denominator of the fraction out. So a square times c square is a square c square on the right. When we multiply on the left, we have to distribute, and we get a to the 4th plus 4k squared. Now we're going to subtract a squared c squared from both sides. I'm going to write it c squared a squared this time. And so we get a to the 4th minus c squared a squared plus 4k squared. Let me pull that up just a minute. We get a to the 4th minus c squared a squared plus 4k squared equals 0. So if we let u be a square, this is u squared minus c squared u plus 4k squared equals 0. So this is a quadratic function, quadratic equation, and so we have the quadratic formula. So if we different letters for than a, b, and c than we have above, but remember the quadratic formula. Let's just go over to the side. Says that if you have a u squared plus bu plus c equals 0, then you get u equals the opposite of b plus or minus the square root of b squared minus 4ac over 2a. Okay, so let's do that with our particular things here. So we get u is, okay, a is 1. So we get a 1 here and a 1 here. Okay, what do we get for b? b is minus c squared. And c is 4k squared. Okay, let's clean this up a little bit. The two minuses make c squared. 2 times 1 is 2. This turns out to be c to the 4th. And this one gives us minus 16k squared. Now that's u squared equals that. But u squared is, that's u. But u is a squared. Okay, so let's go back. And we have a squared is c squared plus or minus c, this is square root of c to the 4th minus 16k squared over 2. Now, so we take the square root of both sides. A's got to be positive, so we square root of that. And actually, the plus or minus actually gives you two values for the possibilities for the leg. And it turns out one of those values is a and the other one is b. So I'm just going to arbitrarily pick a to be the one with the plus. Okay, and so this is going to be a. Alright, it's a little complicated because we had to use the quadratic formula there. Set up a system of equations here, substitute, solve the area for b, substitute that in place of b in the quadratic formula. Look at that and see that that's a 4th degree polynomial which we can solve with the quadratic formula and set that up. Okay, so now we have an expression where we can plug in the c values of 9 centimeters and the area of 18 square centimeters, and let's go ahead and work this out on the calculator. Okay, so square root of parentheses for the numerator 9 square plus, now another square root, 9 to the 4th minus 16 times 18 squared. Close the square root, close the numerator, divide by 2, close the original square root, and this gives us our value for A. So store that as A. Now remember B, we can actually do B two ways. We should be able to actually take that same expression. I believe this is going to work. Let's check it out. And I think if we change that to subtract, we get another value. But I believe that's the same thing we're going to get for B, which is 2 times the area of 18 divided by A. And sure enough, that's the same thing. So there aren't two different cases. Just one of the legs is called A, the other one's B. And so we might as well just choose the plus here and use this formula to find B. Or you can just use the minus there. If you got it all typed in your calculator, that might be just as easy. So there's A and there's B. So let's store that as B. And let's see. We had C already, so now we got all the sides. How about an angle? Well, let's say we were given C, so let's use one of the sides. C and A, let's say. C and A is adjacent and hypotenuse if we're thinking about angle B. So cosine of angle B is A over C, so B is the inverse cosine of A over C. I'm in the mode of degrees. So if I do an inverse cosine now of A divided by C, which is 9, that gives me an angle, and the easiest way to find the last angle is to just do 90 degrees minus what we just came up with there for the last angle. Okay, that was the last case. Let's have you try one before we wrap this up, okay? I know this is a little bit harder, but see if you can do this. So the area is, let's see, let's let the area be 22, and let's let C be 10. Okay, area is 22, C is 10. See if you can work that one out. Try it, work it out, come back, and check your answer here. Press pause now. Alright, now that you're back, the area is 22 and C is 10. By the way, you notice there are some limits here on what we can do here. If C is too small, things don't work out right. But I did give you one that does work, so here we go. So K is 1/2 AB, so B is 2K over A. A squared plus B squared equals C squared. So plug in this 2K over A in place of B squared. We get 4K squared over A squared, so we get A to the 4th plus 4K squared equals A squared C squared. A to the 4th minus C squared A squared plus 4K squared equals 0. Remember, we got this from the quadratic formula. So A squared is C squared plus or minus square root of C to the 4th minus 16K squared all over 2. Square root of all that gives you A. And let's let A just be the one that's positive. Alright, so let's work this out on the calculator. Even typing in a calculator is a little bit challenging. Let's see, we got square root of, parentheses for the numerator, 10 squared plus the square root of 10 to the power 4 minus 16 times 22 squared, close parentheses. That's closing the square root. Now we close the numerator, divide by 2, and close the outer square root. So we get 8.58771 centimeters for A. I don't know if we need this again or not, but let's store that as A. And to get B, two ways to get B. You can either just pull that second entry up and change that to a minus. If you already got it on there, that might be the easiest, but if you really, this formula is easier here. 2k over a, 2 times 22 divided by a, and that's b, 5.1236 centimeters. The cosine of angle b is opposite over hypotenuse. That would be adjacent over hypotenuse. That's a over c. So the inverse cosine of that would be angle b. And now we can use the a and the c. So we can do inverse cosine, or arc cosine of a, which we'll have stored, divided by c, which was 10, close parentheses, and there's the b, and since I'm in degree mode, that's in degrees, 30.82 degrees, and then do 90 degrees minus that answer to find the other angle. Alright, that concludes our set of videos in which we work through all the different possible cases for solving right triangles. Again, the last two will show up on some homework problems, but that's the only time they'll show up. The first 6 cases you should be able to do for, you should get pretty good at those 6. They're not quite as difficult as the last 2. So be sure you can do those without this sketchpad sketch, but you can of course use this sketch to check your answers and so forth. Now, this is an update to this sketch, so if you've downloaded it earlier, you'll want to go ahead and re-download it again because now it has this new part to it.